The next one is 2,6 special functions. The first one is the greatest integer function. Greatest integer function. It will have a notation that looks like this. Don't mistake that for absolute value or parentheses or just regular brackets. It does have a function. So here's the first thing. The greatest integer function, for example, f of x equals the greatest integer of x. What the greatest integer function does is this. Whatever number I put in there, for example, if I put in a 1, then I'll get back a 1. If you put an integer in there of any kind, it's just going to come back to be what that is. A -2. I'll come back with a -2. But if I put in something like f of -3.5, then you're going to come out with something different than -3.5. What is the greatest integer that's less than or equal to a -3.5? Less than or equal to 3.5. The greatest integer that is less than or equal to -3.5. That's less than or equal to. Is -3 less than a -3.5? -4, right. So it would come back to be -4. So look what I just did. I put in a -3.5. And I came back with a -4. So we'll go to the graph. I put in a -3.5. -3.5 is here, but I come back with a -4. So you have to plot that on the graph. And if I go back to -3.5 for this, but then it comes back to be a -4, then I can go here. Here's a -3.5 in this spot. Now -4 is back here, so we're going to go right there on this spot. What if I put in a -4? What would I get back? What's the greatest integer that's less than or equal to a -4? It's what? The greatest integer that's less than or equal to a -4. A -4, right. So it would count there. What if I put in a -3? If I put in a -3, what's the greatest integer for -3? -3. So whatever I put in this area here, between -4 and up to -3, it's still going to be in here. It's still going to be on -4. Whatever I put in up through here. So you're going to have a dot there, and it goes over to this. But it does not include the -3 because the -3 is right there. What if I put in a -2.5, which up here on this graph in blue is here in this mark? If I put in a -2.5, what's the greatest integer? -3. What if I put in a -2.1? -2, still be -3. The greatest integer that's less than or equal to. So all of those would fit into here. But it's not going to include this because what happens when I choose a -2? A -2, the greatest integer that is less than or equal to -2 is what? -2. So we put a solid dot there. And whatever I choose in this area here is going to continue to show up even with -2. So I'm going to go to here and then make a dot because it doesn't include -2. Or -1 I should say, because if I choose -1 here, what's the greatest integer less than or equal to -1? -1. So can you see how the pattern is going now? So it goes to there. And you can continue on this graph. You don't have to go through that in your head or out loud to continue this graph on. So you know you're going to have a dot here. It's going to go over like that. A dot, over, dot, over, dot, and then over. And it just keeps on going. So that is the graph of f of x equals the greatest integer of x. In this case, we have a half times the greatest integer of x. You can create a table if you want to, or you can just write it out like this. F of x, and we're going to use, I'm going to scratch that, we're going to use f of, we'll try a negative 2. If I put in a negative 2, then I'll have 1/2 times the greatest integer of negative 2. What is the greatest integer of negative 2? Negative 2. What's negative 2 times a half? It is negative 1, right. Negative 2 times a half is negative 1. So I put in a negative 2. So I'm going to go back negative 2 to here. And I came back with an answer that was what? A negative 1. So I'm going to go back to here. And then make the dot. So what happens if I put in something like this? What if I come back with f of negative 2.5? So I'm going to have 1/2 times the greatest integer of negative 2.5. What is the greatest integer of negative 2.5? Negative 2, think of it as negative 2.5. What's the greatest integer that's less than or equal to negative 2.5? Negative 3. You were right. I don't think I heard her. I didn't understand what she said, but it is negative 3. So if I had a negative 3 for this, then I would multiply that by 1.5. What's negative 3 times a half? Negative 1.5. So we put in a negative 2.5, and we have to go up to, and we'll go ahead and write the answer here, negative 1.5. So we went back negative 2.5, and negative 2.5 is here. Then we have to have a negative 1.5. So it falls down in this area here. All right, what happens if we put in this? F of negative 3. So it'd be 1/2 times the greatest integer of negative 3. What is the greatest integer of negative 3? Negative 3. What's negative 3 times a half? Yeah, negative 1.5. So if we went back to negative 3 and then 1.5. So here's negative 3 here, and then 1.5, it puts us here again. So notice it's going to go over to here, make it to this point, but it's not going to go. So now can you figure out a pattern from this, or should we go ahead and do the negative 1.5? How about we do the negative 1.5? We'll go to f of negative 1.5, which is 1/2 times the greatest integer of negative 1.5. What is the greatest integer of negative 1.5? Negative 2. Okay, so we're going to have 1/2 times negative 2. What's 1/2 times negative 2? Negative 1. So we put in a negative 1.5 and came back with negative 1. Negative 1.5 is right here and came back with negative 1. So it falls in right there. So this one's going to go to here, and you can't get anything. So where's the next one going to show up if I stair-step this upwards as a positive slope since it's 1/2? Where should my next thing go? Am I getting warm?
Directly up from the one that's not clear, but halfway right there.
Okay, so we'll go here and then go over and do this. See the pattern? The question is, how do you know where to plot it? And you have to remember that, and we'll use this problem here. We'll use this. What you're putting in there is x. That's your x coordinate. What you get back is y. So we put in a -1.5 and came back with -1. So you know that's where to plot it. Now you don't have to make a point every single time on this graph because you just need the solid dot, the line, and then the open dot. So if what you're plotting in there or plugging in comes out to be on that line, there's no need to put a dot. For example, up here, if I go back through and do this, this one, we put a dot there, but it's really unnecessary because whatever you choose within a certain range is still going to show up in here. It could fall on that dot and it'll go up to, but not including this spot here. That's why it's an open dot. So you don't have to choose like 5 different things in here and plot 5 little dots in between those two. You can figure out what it's going to be between after you do a couple. Piecewise functions, you're generally going to have 3 different things you have to graph. Here's an example. You have f of x equals x plus 2 if x is less than 0, and then f of x equals x if x is 0, and then f of x equals -x minus 2 if x is greater than 0. Section off your graph, and you don't always have to draw this, but we'll do it in red. So you have 3 different items here, and we're looking at this part first. If x is less than 0, so that means I'm going to concentrate on stuff that is less than 0. And I'm also going to concentrate on stuff that is greater than 0. But if it's 0, then I just have a dot here. Because if f of x equals x, when x equals 0, then you just put a dot on 0. There's nothing left to do. So that middle thin part in there is already taken care of. Let's look at the right side first, and the right side is x greater than 0. If that's the case, then it's -x minus 2. You have to remember how to graph this. -x minus 2. Just go down to -2 on the y-axis and make a dot. And the slope is -1 from right here. So you go down 1 and over 1. So here it is, down 1, over 1, and we draw this line, except that line cannot cross 0 because it says it has to be greater than 0 for it to be a -x minus 2. So when you draw this line, it's going to look like this. It cannot continue all the way through the graph. It's got to stop at 0. So we've taken care of this and this. Now the other one is x plus 2. So we'll go over to the y-axis, and we're looking at this equation. The y-intercept is 2, so go up to 2 and make a dot. The slope is +1, so we go up 1 over 1. Up 1 over 1. But this is only if x is less than 0, as it says here. So it cannot cross 0 and go over to the right. So what we're going to do is draw this line, except it's got to go. You can only include this. So it'll go back that way. And that is the piecewise graph of that piecewise function. Notice that you had x plus 2, here it is, but it can't go across 0 because it's got to be less than 0. X is just 0, so you put a dot on 0. and negative x minus 2 if it's greater than 0. So we made this line, but we can't take it across 0 into the left because that would be less than 0. It says greater than 0. On this problem, you have one where it's between negative 4 and positive 4. So if you go on your graph and not try to, there we go, I had to take that out, not try to mark all over it. I need a smaller marker. But in this case, we'll do this in red, negative 4 to positive 4. So we're looking at 3 different areas sectioned off like this. There's negative 4, and here is positive 4. And you go through and do each one, but make sure you keep it within the boundaries of where it's at. So for the very first one, 2x plus 1 is for x less than negative 4. That's this area over here. So you can still go to your y-axis and put a plus 1 like this. And the slope is 2, so you go up 2 and then over 1. That's the same as going down 2 and over 1. Down 2 and over 1. Down 2 over 1. Like that. So if, on this graph, the only thing that shows up on it is this little spot down here.
So you can't mark inside the boundaries then?
Now your line can't go through there. And then for the middle one, between negative 4 and positive 4, it's x minus 3. So if we go to negative 3 and make a dot and the slope is up 1 over 1, that's pretty simple to graph. And it's just going to go, it's not on forever, so you cannot put in these arrows. It just goes over and stops. And it just goes over and stops. And you could have a dot on this because it must include that. And then you can go take a look at the one on the right side, greater than 4, it's a negative 2x minus 1. So we'll go to minus 1 here, and it's a negative 2, so you go down 2 over 1. And we have to keep going down 2 over 1, like this. And that one's not even going to be on there, so I'm just going to extend it a little bit. And it kind of goes like that. So there's the piecewise function. The absolute value function, this is just a matter of plotting. So you would have, for example, f of negative 2. If I plugged in negative 2, I'd have the absolute value of negative 2 plus 1. Negative 2 plus 1 is a negative 1, and what's the absolute value? 1. So if I plug in a negative 2 and I come back with 1, I go back 2 and up 1 and make a dot. And that's it. But you have to do that repeatedly so that you can come up with the formation. The formation for absolute value graphs is going to look something like this. It's going to be a V shape, either opening up or opening down, depending on if it's a positive or a negative that you start with. So you should put in enough of those points such that you can see the turn. Let's say we plotted this one, and we get another one, and another one, but once it starts going back up like that, you know you've got the V shape. So you can connect the dots and then carry them on out. And in the interest of time, we can't finish this one, but it's pretty simple. It's just a matter of filling in some integers, plotting the points, and then connecting the dots to make a V shape. Once you see the V shape forming when you're connecting the dots or plotting the dots, then you'll know you have it.